Okay, let's do some apps on the things we have been learning, right? Indefinite integrals, definite integrals. Okay, so we are on the section 3.6, applications of definite integrals, area between curves. Also, we are going to talk about average values on your page 72. So, which section was it? Section 3.2. I think we were learning what? Indefinite. 3.1, we were learning what? Definite integral. Right? So, let me double check. 3.1. Yes. Okay. So, what the 3.1 was saying, okay, if we have a curve like this, it's above the x-axis or positive value, right? This is your f of x. If we take antiderivative of this curve from a to b, right, against the x, when we take antiderivative of this line, it ends up is same thing as is the same as the area, right? Under the curve. It ends up same. So if I wanted to find the area under the curve, I can just do what? The antiderivative of this function of the curve, take antiderivative for the definite integral from a to b, I end up same. That's what section 3.1 was saying. Okay, so we are going to use this concept to do what? Something called average values. Then we see why we have to learn that. Okay, so before we go to find the average values, we practice some more. Instead of just area underneath the curve, we are going to learn the area between two curves. If I have two curves like this, I want to find the area in between, okay, from time A to time B, okay? So, that's how we are going to use the formula. Okay, so the area and between the curves, if I have two functions, one is called f of x, one is called g of x, right? So if I have one curve is f of x, one curve is g of x, then one curve is bigger than the another curve, the value, y value, okay? If we have this situation, so that's your x and y's. So if we want to find the area in between, okay, we use this formula, okay? So the area between F and G, okay, from time A to time B, okay, is we do this way. We do what? Antiderivative of f of x minus g of x. F is bigger than g, so this one is always positive. So your area will be positive, right? Because the area cannot be negative. So we are going to use this thing to find the area between two curves instead of what? Just under the curve, as we said in section 3.1, right? You can see, obviously, if you do f of x, that would be the area, okay, under the f, this big part. Then g of x would be the lower part. So your top part, total minus the bottom part, then that would be the things in between, right? So we will use this idea to do something called average values later. Okay, so this section, so far for 3.6, we are using the 3.1 to do that. Okay, so we practice that first for the skills, how to find the areas in between the curves. Okay, so let's see some example. So find the area between this 3x squared plus 4 and another one 2x minus 1, right? From x is -1 to 2. Okay, so what do? Do the graphs. Use your calculator, right? To do the graph. Or go to the website. So first one is what? Quadratic function, right? You learn in your 154A class. Is what? Parabola. And opens up or opens down. If it's positive, opens up. Right? When x is 0, y is 4. Then you do your graph. You should have parabola like this, right? And next graph, that would be what? A linear, right? Y equals mx plus b. So the m is 2. So your slope is positive. So it goes up from left to right. So x is 0, y is what? -1, right? x0, y is -1. Then y is 0, x is half somewhere. Okay, so the line look like this. And we say we want to find the area between what? These two lines, between these two lines from time -1 to time 2, right? So that's your 2, then that's your -1, say -1 and 2. So that will be here, right? So the area you want is what? In between. We want you to find out how big the area is between these two lines. Okay? Then we say, what do? We use this formula, right? So we will do what? Antiderivative of 2 curves, right? 2 graphs. So you do f of x minus g of x, then take antiderivative of them against x from what? -1 to 2. So what do? So we plug in f of x is what? 3x squared plus 4 minus 2x plus minus 1 to do the dx of from -1 to 2, right? Then we simplify them, and which will be what? 3x squared minus 2x plus 5, right? So we take antiderivative of this for the definite integral. So what do? We do the antiderivative of this polynomial, right? Use the power rule and sum and difference rule, so you go up one level, right? So end up, you should know by now, x third divided by 3 cancel with 3. That would be this one, and minus x squared plus 5x. That's indefinite integral plus c. But if it's definite integral, what do? We say you will use the fundamental theorem of calculus from your section 3.2. So you do what? From -1 to 3, you do this way. Okay? Then how to find the value of this thing for the integral? That's how we use, right? This method. Then you plug in 3 to here, plug in -1 to there, and subtract them. So that will be what? 21. So the area in between this will be what? Square units. Whatever the units we will use by the square. Okay, that's how we use this formula to do the find the area, find the value between two lines, okay, two curves. So then let's see next one. If we have this, finding sales from extra advertising. It says a company marketing high def television sets, okay, expected to sell them at a rate of what? 2 to the e to the 0.05t. Okay, somebody did a study and say, okay, my model will be this way. My f of x actually is f of t, because according to the time t, right? 1 month, 2 months, 3 months, right? 1,000 sets and per month, where t is number of months since they became available. However, with additional advertising using a sport celebrity, they find out they will have the sale will be what? Become 3e to the 0.1t, bigger, right? Bigger number. So how many additional sales would result from the celebrity endorsement during the first year? So for the first year, then those model is what? The rate. That means each month you will get more as such. Okay? So if we do the analysis, its analysis is only a estimate. Okay, let's see. Then we wanted to see what's the difference between them. That means result from what? Additional sales. We want to find out. So additional sales will be what? 3.1t minus 2e to the 0.05t, right? Then after the first month, 1, 2, 3, so 12 months. we are talking about, right? So I just plug in this formula on the spreadsheet. Then I enter all those things, or you can use calculators, okay? But spreadsheet is much easier. Then I calculate this value, okay? Then I just use 1 decimal point to do the estimate. Just write it down for you, so see you can, go to Math Center and figure out how to use spreadsheet or calculator to find those values. It would be very handy for you, for your job applications or actually doing the job, make life much easier. So I estimated from here is what? For the month 1, I will have 1.2 thousand sets per month, more for each month. That means for this month 1, month 2, month 3. So when I add all them together, I will have total around how many? Then 39.4 thousand sets. That means I will sell so many more TV sets, okay, during the first year. So I'm just doing the analysis, okay? Then let's see what happened if we use integral. What does that mean? Okay, so when you graph it, for the first one, x and y, right? So x is your t according to the time from month beginning 0 to 12. So when you use the website, when you graph this one, g of t will be something like that. Okay, then your f of t, that's your g of t. So f of t is this one, 2e.05 t. Okay, then we say those are rates, okay, rate for both of them. That means the changing rate is not the total. If it's total, you just minus them, you find the difference, right? Then the model is telling us, they accumulate the data for each month. They realize, for the month 1, they can, sell so many. If with advertising, they can sell so many. So difference is around 1.2 mil, 1.2 thousand sets. Okay, so we said if it's a rate, right, then I find the antiderivative. That would be my total sale for the regular. But with advertising, that would be what? Bigger sale, right? So advertising is bigger than the regular. So the difference would be this, right? So I take the antiderivative of the rate. That would be the total sale. Is that right? Okay. Then from month 0 to 12. Then against the time, right? Even without seeing the picture, you take the antiderivative of the changing rate, the rate of change. That would be the total, right? Total sales for the advertising one and the regular one. You minus them, right? Then the way to do it, this is just your visual part of it, okay? So we take an antiderivative. It's the same thing as finding the area below the curve. So if we look at the visual effect, that means if I find the antiderivative of these two, the difference means I find the difference in these two areas. We are going to use these concepts for other purpose. Okay, that's why we use this. Otherwise, we can just directly use this antiderivative of rate of change, the difference, right? That would be the total. So we plug in, that would be what? 0.12, 3e to the 0.1t minus 2.05t against t, right? Then we use sum and difference rule and what? Not the power rule now, is exponential function rule, right? Then you take antiderivative, okay, which will be what? 3 times e to the 0.1t divided by 0.1, right? Minus this one, 2 times e to the, use chain rule, right? Then, for the definite integral, we can just do what? Use the things for the area below the curve formula. We plug in 0 and 12. Okay? Then you plug in your calculators. It's about what? 3.7. So, what is this one saying? The answer, it means it should result in how many thousands sets, right? That would be 700 additional TV sets and cells, right, during the first year. Okay, so you can see a little bit different from actual calculating and from the estimating. Okay, the analysis just do the estimate, because you see, when we have the integral or this curve, we say they have to be continuous. So it's like if you have continuous compounding and periodic compounding, like this one, just monthly, right? Compounding, then you have different answers. So we need to use what? Continuous compounding style, for the money, then for the difference of the, the rate of change with this idea. So we wanted to do it more accurately, just like you usually, right? If you do the CD or, deposit in the bank on the CD, usually you do continuous compounding. Okay, so we use continuous curve, and then those are periodic, just discrete numbers for the analysis, for us to do what? Estimate, to see the concepts more clearly. That's why the numbers are not exactly the same, okay? But to be more accurate, we need to do the calculus way. Got an idea? Right? So antiderivative, what we are saying is antiderivatives, okay, are the same concepts as the visual effect of the area underneath the curve. Okay, so we practice some more with the area under the curves. Now is the area between curves. Okay, so let's see. Finding the area between curves that cross, like those two lines, two curves are now crossing each other. So if we have this one, y equals 12 minus 3x squared, and y equals 4x plus 5. One is what? A line. One is what? Polynomial. Second degree is quadratic function, right? So x squared leading coefficient is -3, is negative. So it opens up, opens down. That one is opens down, right? So what do? Why don't we just graph it? Okay, first one, parabola, opens down. X is 0, y is what? 12. Okay, so it will look like this. So it opens down. All right, then we want to find out the area for x is what? From 0 to 3. Okay, then for the line, this one positive slope, so it goes up from left to right. So x0, y is 5. Okay, so something like that. Okay, so what do we have? We have this way, right? Then we say we want to find the area between these two graphs from 0 to 3. So where it should be? Between 0 and 3, between these two curves, one is here, one will be where? Here. Is that right? Okay, so this one is a 4x plus 5. And this curve, that's that would be that, right? Then, if you use the black one minus the blue one, then black one minus blue on here will be negative. We don't want to do that. Area is not negative. So for these two areas, we have to do it separately by the breaking point, right? Where is the breaking point? Where they meet. Okay? So you have to find the meeting place here. Then, how do we find the meeting place? They have, okay? We do this. Y equals what? 12 minus 3x squared. Y equals what? 4x plus 5. Does that look familiar? If you put a curly bracket there, then you do what? Solve a system of equations, right? We learned this in your 154A class. Okay? How do you solve it? You can use a substitution or you can use addition. As long as you eliminate one variable first, right? Like you have y, they are the same, you can just sub in because they are the same, or y's, right? So you just put it in by substitution. What do we have? 4x plus 5 equals 12, 3x squared, right? Then you put the two variables, two equations into one variable, one equation, so we can solve it, right? Not the standard form, but what kind of equations we have? Quadratic equation, right? I'm going to move all this way. So I have what? 3x squared plus 4x minus what? 7 equals 0. Okay? Then you do your factoring. So what do we have? Okay? If you don't know how to do factoring, then you do what? You use the quadratic formula. Either way will work. Okay? But sometimes factoring is easier. So you will solve your x. X is what? Negative 7/3, or x is 1. Okay? But we are talking about in an area is what? On here, right? Between 0 and 3. So we don't have to worry about this. So ignore. Okay, we just use this. When x is 1, what's your y? You plug in. X is 1, right? And 4 times 1 plus 5 is 9. It's right here, right? So this point is what? 1 and 9. Is that right? Okay. So then what was the question? To find the area between the curves. Okay? So we want to use what? When we use this formula, we need to use what? Bigger one minus smaller one. So that's how we do. So your area will be what? We do from 0 to 1 first, then black one minus the blue one, right? So you will do 12 minus 3x squared, right? Minus 4x plus 5 for the x, right? That would be this area. Then for the second area is what? From 1 to 3, right? This is 1. Then you need to do what? Blue line minus the black one. So you will do 4x plus 5 minus 12 minus 3x squared. So against x. So what do we do this way? Because to make sure the area is positive. Okay? Then you do your antiderivative. Okay? Then follow the definite integral method. So antiderivative is this one. Then for the definite integral between 0 and 1, you calculate this way using fundamental theorem of calculus concepts, okay, to interpret, to find the value. Then for this one, would be the opposite actually, x cubed plus 2x squared minus 7x would be the opposite, right? From 1 to 3. Then you plug in your value, okay? So that would be 32, which is square units. So that's how we find the area between the curves. Okay? All right. Let's do one more practice for finding the area between two curves. Okay, look at the next one. Find the area bounded by curves. Okay, so it says one is 3x squared minus 12. Another one is what? Y equals 12 minus 3x squared. They look the same, but different signs. So first one is parabola. Both are parabolas, right? This one opens up, this one opens down. Okay? So this one opens up at 12 vertex. Okay? Then x is 0. Y is what? Negative 12. When y is 0, x is what? 2 and 2. So yeah, 2 and 2. 2, negative 2. So your curve will look like this. Opens up, parabola, right? The next one, parabola is opens down, 12. Okay? Then it looks like this. Right? So, the question was, find the area bounded by these two curves. We want to find this area. It didn't tell you like here from 0 to 3. But the bounded by two curves, you can see it's where? Negative 2 and 2. Right? By graphing. But how do you know they actually meet there? You need to solve your equations. So you have y equals, that's why we have learned this in your 154A class, right? By substitution or addition method. So you just put it back in. So you have negative 3x squared equals what? 3x squared minus 12, right? Then we move to here, move to there. Okay. Then what do I have? I just plus 3x squared. Right? So I have negative equals 6x squared minus 12. I plus 12. 24 equals what? 6x squared. Then I divide by 6. X squared is what? 4. Then what's your x? By square root property, don't just give me 2. Because you have what? Plus or minus 2. Right? If you plug in, then y is 0. So they meet here. Then question was, find the area bounded by these two. Right? So we use what? The blue one minus the black one, because blue one is bigger, is positive value. The thing is, definite integrals bounded by those two numbers, you have to specify from lower end to the higher end. Then you do the blue one. The blue one is open down one, right? Opens down. That would be this one. Right? So you will do what? 12 minus 3x squared minus 3x squared minus 12 against x. Then you do your antiderivative. That will be 24x minus 2x cubed. You need to do it yourself, right? Then for the definite integral, what do we do? From negative 2 to 2, right? Then to calculate the value, you just plug in. Turned out it's 64 square units. That's how we do. So the difference between these two is what? This one is telling you from 0 to 3 for x. It tells you already. Then you need to find the positive area. So you need to split it to 2 parts, right? Because area is positive. And this one is bounded by these 2 curves. It didn't tell you the definite area from when to when, from -2 to 2. Now you have to find it yourself. So you can do the top minus the bottom curves. So what you need to do is you need to graph it to see it at this level to do it first. So you should be able to find that the areas are positive for sure. Okay? So we are practicing what? The definite integrals between curves. Then next one, we are going to use this concepts to do something called average values. Okay, let's see. What do average values have anything to do with, the area between the curves? So let's see the concepts of the average. Why do we care? Right? When do we use those average things quite often? One is possibly we have what? Talk about birth rate, birth weight, okay, of babies. So when they have a baby, then they say, oh, how much he weighs, he or she weighs, right? So we know to compare to what? The average weight. So kind of baby is relatively on heavy side or, pre-birth, these type of things. So we want to know average of the baby's weight to compare, right, for the birth weight of babies. Another one is we use quite often is the retirement benefit. So retirement benefits are determined by average income. So compared to with the what? Average income. So for your retirement benefits, then you figure out, okay, am I doing okay or should I be concerned? So for your reference to compare with average income, then with your retirement benefits. Okay, another thing we use quite often is average temperature. Okay, if a temperature is a function, right? So what's the average temperature for this month? If it's, 10-degree difference, that would be a concern, right? So we use a lot of average for our, purpose. So that's the average. Then how do we calculate the average? Because we want to know average of the, baby weight, right? Then or average income. How do we calculate average income? Or how do we calculate average temperature? Of course, you can add all up and divide, but sometimes it's not that trivial, okay? So we use the calculus method to calculate to make things more accurate. Okay? So if I do this way, everything goes back to the function, then with the picture, right? So from time A to time B. Okay, so if it's all same, average is very easy to calculate. But sometimes it fluctuates like this. Okay, so it's a function like that. All right. So I want to find, okay, so that's my function. It's a curvature, right? It's a curve. Then what's my average of this curve? Okay, so this is my function, like temperature, right? So question is, what is the average of the curve? That means the function. What's the average? You know, like temperature sometimes up, sometimes down, right? Like this. Then what's my average? So average is everybody the same, so average is around here, say. That's my average, that's my number, right? I want to find this number. So if it's average, it means what? The original area under the black is this, right? If it's average, the area will be what? Under the red. Should it be the same? Of course, because this red line is the average of the black curve, right? They should be the same. Okay, so for the average area would be what? Base times height. Base times height. Right? Then for the black area underneath the curve, right? Original area will be what? We say the antiderivative of the, right? The function. That was that one. Right? So then for average area is this one, the base times height, right? So the base is what? Base is from A to B, right? So it's B minus A, that's A, right? So your height, so height would be what? Area divided by base, which is what? Area divided by B minus A. Is that right? Then what's your height? What's your height? For this height. Height is what? Your average. Is that right? So your height is what? Your average. So we say what? Average becomes what? Area divided by B minus A. Then from the concepts we have learned for this curve, if you take antiderivative from A to B, that would be your area. Is that right? So that's your area divided by what? 1B minus A. Turned out is what? That's your average. So we are using the we are using definite integral concept from section 3.1 is saying what? The area is the same thing as you take the definite integral of the antiderivative of the curve. Then we use that concept of the area divided by base. It becomes what? Our average. That's how we find the average more accurately with this formula. Okay? So that's your formula for the average. You use, if I want to find the line like this, if I have a function, what do? Find the average of this thing is here, right? That's my average. So all I need to do is what? Use the function, right? Find the antiderivative, then divide by b minus a. Then I find my average. Okay? So if you want to find the average from time A to time B for a certain model, what do? You do the antiderivative of that model, find the definite integral between that time, then divide by the difference of time. Then you find your average. Okay? So, that's how calculus calculate the average. Much more accurate. Okay? Let's look the example on your page 74, right? So, first one, finding the average value of a function. Let's practice that first. Okay? Just doing straightforward. So, it says, during a 9 hours workday, the production rate at the time t hours after the start of the shift was given by the function of the rate according to time 5 plus square root t cars per hour. They produce so many cars per hour. Find the average hour production rate by hour. Say 9 hours a day. Okay? So, it says production rate. Okay? So, let's do some analysis. Means estimate. According to this rate. Not completely accurate. It's just estimate. Okay? So, what does it tell you at what kind of rate? Okay? So I'm just going to use the good number. How many cars will be produced at that rate per hour? At hour 1, let's square the 1, they can produce what? 6 cars at the first hour during the workday. Then at the 4th hour, then square root 2 plus 7, they can produce 7 cars at the 4th hour. At the 9th hour, square root 9 is 3, they can produce what? 8 cars, say. Right? Of course, it makes difference, it fluctuates, and this is only estimate. So, what's the average? Would be what? In between, right? From 6 to 8, 14 divided by 2 is 7. So, average about 7 cars per hour, each hour. Okay, according to analysis from the model is given, right? Then, if we do it more accurately with calculus method, what do? That's the rate, right? then antiderivative will be the what? The total. But we want to find the average per hour. Average of this rate. So average, we say use this formula. So the average would be what? The 9 hours time, right? From hour 0, T is what? From 0 to 9. So B, A is 0, B is 9. 9 minus 0 for the antiderivative of what? A to B, time A to time B. Then you take antiderivative of this thing against time. If you do this formula, then that will give you the average of this rate. Right? So what do we do? 5 plus half of t to the half power to the dt. Right? It's just a polynomial style rational function, right? Then you do antiderivative. That would be what? 5t plus up one level 3 halves divided by 3 halves. Then for the definite integral, we do what? 0 to 9. This way to find the value, right? Then times what? 1/9. Then you plug in to this. So that would be what? That's a 3 halves. All right, then you plug in, that would be 7. It means what? 7 cars per hour. That's what it's saying. So we use this average because like we have what? Time 1.2, 1.3, 3, all kind of numbers continuously, right? For all the numbers, we need to do the calculus way. Those just discrete number, because in between hour and 2 hours, then you still have 1.5 hours still working to do the cars, right? To produce the car. So that's how we do it with the average value. Okay, use this formula. Next one, finding average population. It says the population of US is predicted to be, that's the population according to the time, that would be 310e to the 0.0073t, right? Million people, so many of them. And where t is the number of years since 2010. Okay, before 2010, you probably have different models. Then this one, somebody did a study, okay, say since 2010, population will be expected to grow in such a rate. Then predict the average annual population between the year 2020. So what happened to 2020 to 2030? What's the average population? So the source is from U.S. Census Bureau. So this number, this exponential function is real in the real world. Okay, somebody did a study, produced this model at the year 2010. Then they say, okay, what kind of projection we have during this time, 2020 to 2030, what's the average population, right? So they can allocate the budget, then do whatever the services they need to provide. Okay, so we want to find the average population between this time. So your average should be what? So since 2010, so 2020 will be what? would be 10 years after. This would be 20 years after. So between 10 and 20 is your A and B. So it's B minus A, right? So 20 minus 10. So your integral for the average means between this time, then you take an antiderivative of the function for that against time. Then if you divide it by that, that will be your average. Right? Then you do your math, then that would be 31 times 0.0073 T, E, that's your E, 0.0073 T divided by chain rule as such, then between what? 10 to 20, right? Use this to calculate the antiderivative of definite integral's value. Then it's about 346. So what are we saying? You will about 346 million, right? People average during the 2020 to 2030 for each year. Average out. Got idea how to use the average value to find the average value of the curve by borrowing the concept of the area. Okay, to find the average. That will be our section 3.6.